Where arithmetic is patterns found within counting, algebra is patterns found within arithmetic and numbers. To fully prepare for algebra, we need to focus on a new skill that is not encapsulated by counting or arithmetic. This skill is finding similarities and differences between numbers and arithmetic operations. In essence, we are moving into a categorical role to classify what we have discovered thus far. Most in public school today never spend any time classifying patterns on their own. This is because these concepts are already precisely defined. Instead, we spend our time learning the definition and move on. I think for the most part this works well, but leaves students confused about application. Building this classification is outside the scope of this course and tends to be more rigorous than a non-math person would expect. However, I will try to provide insights into what this looks like from a practical standpoint, as it is helpful in understanding algebra as a whole. In the arithmetic and counting sections of this course, I mentioned that arithmetic is built on patterns identified within counting. Addition is counting up from a number. Subtraction is counting back from a number. Multiplication is skip counting forward. Division is skip counting backwards. There are other definitions of these patterns. For example, addition could be defined as the cardinality of the union of the two disjoint sets. Well, this is more in line with how mathematicians define addition. This course will not attempt to make sense of it, but this new definition is an acknowledgement that the simple definitions do not capture the full capabilities of addition as a concept. We need other forms of math to understand why. What may not be fully recognized by the beginner arithmetician is that arithmetic is limited. It's a powerful tool and a great start, but it has barriers. These barriers can be recognized by the classification system I'm trying to describe. Algebra is built to overcome these barriers and provides additional tools to help create a more robust set of problem-solving tools. The bridge over the barrier is created with a few definitions that are critical to understand before venturing into algebraic territory. These ideas are known as variables and unknowns, order of operations, and mathematics as a language. I will do a deep dive of each of these in later videos, and will use the rest of this video to introduce why they are necessary. Arithmetic by itself leads to the realization that calculations can be performed with unknowns as well. For example, 5 plus 7 equals 12. Do you know of other values we could substitute for 5 or 7 to get the same answer? We could use 6 plus 6. Let's list all possible ways to add two numbers to get 12. The ability to substitute numbers and get the same result is a foundational property of numbers, and our first classification. Mathematicians have given this property the name variables. Variables unlock the ability to work with unknowns. They unlock the ability to ask questions like, can we start with the answer and derive the original question? This highlights a limitation of arithmetic. Arithmetic by itself requires us to list all possible outcomes one at a time. Adding two values to 12, for example, we have 13 to list in total. That's exhausting. Can you see that half of these additions are the same? Is there a way to only list half of them? Next, consider all of the ways we can subtract to get 12. Unlike addition, subtraction doesn't have an end to the list. It just goes on forever. This comparison highlights the fact that arithmetic operations do not always provide the same behaviors. which in turn hints at the need of a classification system. Counting by itself only includes positive numbers, and we give these numbers a specific name, the natural numbers. The natural numbers are those we learn naturally, 1, 2, 3, 4, 5, and so on. To understand the limits of arithmetic, it is important to recognize without additional number types, we only have the naturally learned numbers to work with. In other words, we cannot rely on negatives or fractions. These two number types were invented/discovered to unlock the power of chaining operations together. Mathematicians have spent time categorizing and organizing properties of operations. In essence, arithmetic operations have different results depending on how you chain them together. They have compiled this work into what is known today as the order of operations. This is an oversimplification, but should satisfy most non-math people. Luckily, mathematicians have already done this work, and we just need to know the definition of the order of operations. The last element we need before we move on isn't a limitation of arithmetic so much as it is a recognition that with so much variability, we need definitions to ground us in a common goal. Language is the best tool humanity has developed to date to do so. Unfortunately, language has its downsides too. Ambiguities in language can lead to miscommunication and creates a barrier we may never fully overcome. To summarize this section, we are making preparations for algebra. Algebra requires us to classify operations and numbers. We call these classifications properties of numbers and properties of operations. This classification of numbers and operations introduces ambiguity in which properties we choose to highlight, thereby introducing mathematics as a language. Before we can discuss algebra in full, we will spend more time on each of these classifications as well as the language element to fully prepare for the next steps. I will do this over the next 3 videos.